Hello, everyone. I'm Mani, CTO of EnergyWeb, and it's great to be here at Web3 Summit. Today, I want to ask a question we rarely confront, and that is, what guarantees do we actually have that the logic behind some of our most critical workflows is exactly executed correctly? Because the reality is that we have spent years optimizing uptime. But uptime isn't really the same as the correctness. And statistics actually show that uptime alone can protect us when the logic is actually flawed or manipulated, or maybe it's silently broken. So that is really the journey that led us to build worker node networks at EnergyWeb, or in short form, we call it WNN. So just a quick snapshot of the EnergyWeb, so for all of you to be aware, like EnergyWeb was launched in 2017 as a nonprofit with a very specific focus and mission to decarbonize the global energy sector, but mainly by building open source infrastructure. Specifically, we are using the blockchain technology and decentralized aspects of it. So just like since launching our technology has developed over hundreds of energy companies across like 17 different time zones. I mean, spanning from the utilities, transmission operators like Fortune 500s and national regulators. So some of the logos that you see aren't just our customers. They're members of our ecosystem, and in many cases, they are the validators on our blockchain. So everything we do, it centers around trusted coordination. But this is across a lot of markets and assets and organizations. So, but on the left, you see Digital Spine. This is basically the solution which is powering real-time coordinations between energy market participants, which is live in Australia. And in the center, you see other solutions based on green proofs, which is basically supports multiple use cases like carbon-aware compute, sustainable Bitcoin mining, and maritime or aviation fuel traceability. So this is really outlines the structure of my talk today. So what we have built is really the system for a verifiable logic execution, which is backed by decentralized assurance. What does it actually mean? Why is this even needed? And what problems is actually trying to solve? And what kind of characteristics a particular solution to overcome that challenges need to have? Right? Technically, we will jump into that. And then how it works in practice for all the enterprises' perspective, and also showing you different types of personas. And I will also walk you through how is it actually implemented, like the technical architecture, structure of it. And finally, what activates it economically. I mean, that's something very interesting for the Web3 folks, right? And how the value actually flows through the system and secured on-chain. So when the logic fails in mission-critical systems, the damage is really fast and massive. These are just some examples, right? But you can see on 2021, like the Texas grid failure led over 200 deaths, but most importantly, that 130 billion in damage. Death is, of course, is very unfortunate. That's the worst aspect of it, right? But that's nothing the technology can actually protect, right? So what we can do, we can look at over here that the problem was not really the downtime, but really it was the coordination logic breakdown across the grid operators. And all other examples, these are really the silent failure, of the correctness. And they cost lives, reputations, and the companies go bankrupt. Billions of money is lost, right? These are all off-chain computes, right? We don't have an issue with the blockchain technology. Whatever runs online is all fine, right? But just look at this pattern. It isn't really limited to the energy or finance. It actually shows up everywhere. So it's not really about uptime. It's about unverified logic and the lack of multi-party coordination or fairness, that we call it, right? So we are seeing billions of losses, right? Not because of the system were really offline, but because one could prove that the right logic, when it mattered the most, was really the right logic or not. So, and more than that, this is actually getting worse. In 2022, like global software automation failures actually cost 2.4 trillion. This is not M and B, it's T. So nearly a third of the major data breaches are all caused by internal logic failure or configuration errors. And in carbon markets alone, right, over 2 billion in offset were actually misused due to inconsistent rules or double counting that occurs. So that we will talk about. So these are all aren't about outages, right? So these are all failures of the trust and how the logic it actually behaves. So they're happening faster, and they're happening at the larger scale, and they're happening in more domains than ever before. So let's say we all agree that unverified logic is one of the biggest risks of today, right? Now the question is, what would it actually take for such kind of Web3-enabled infrastructure to be trusted? And that's really the main problem that we had. And we tried to solve it for the past 7 years, working with a lot of regulators, enterprises around the world. So I think there's lots of text over here, but I will summarize it in the next slides, right? But these are really the 4 main categories of the challenges that we face. And each of those categories, they were really non-negotiable for us at all. And just to remember, there is a need to be able to replicate the exact same solution for each business process, right? So let's look at the governance, right? So we needed to define who can actually run the compute, or basically perform a KYC or K by B of the operator. And then we realized the public proof of stake, right? Of course, it gives you not much of control, while the private proof of authorities basically give you not really a true or enough decentralization. So we had to support a governance participation. Just imagine the smart contracts. We are here talking about only off-chain, but just imagine smart contracts that need to be chosen who can actually be validator on each of those contracts. And if anything that happens, what actually protects us against something going wrong over there, right? So they want more public participation. Why? Because they want higher security of that solution, right? If the solution is in less than 10 minutes, it costs 100 million, there should be a security equivalent to that amount to be able to protect the losses, right? So the second one is the logic execution. So most of the enterprise workflows, or for example, dispatch coordination, right, or the carbon issuance, they are a very complex logics. They are not something that it can be easily executed on smart contracts because they also, in fact, need to be integrated with a lot of external data sources, and they need to have a multi-party coordination among them. The other aspect is basically the incentive, right? So you need to be able to provide the right incentive to attract more people to have the more security. How do you actually procure that incentive? How do you configure it? because this means is a proof of stake per solution, per logic execution. So just imagine we need to launch a proof of stake for an enterprise is a regulatory nightmare. So we cannot really rely on existing technology stacks that we need to do a lot of customization. You have seen all the parachains, and we are all moving towards the agile core times, right? And elastic scaling, and now we have the jam that is coming up, right? But we would require to have also this very specific tokenomic design for each solution. The last one, which is a very important one, right, is how the procurement of such a solution works for enterprises. You know that with all these recent adoptions, Bitcoin or stable coins, it's really not an issue for enterprises to make payment. But here we are not talking about making the payment. Here we are talking about the fiat transform into a trust layer, not fiat transform into a payment. So that's actually something that you need to think of, right? There are like fiat RAMs that there are some virtual IBANs is issued to the entities, which of course KYC, and then you can transfer an amount to that virtual IBAN, and you will receive some funds on a blockchain address on any kind of chain. Or you can specify what kind of crypto or digital asset you want to receive. But that's also another form of fiat to the crypto or the payment. It's not a fiat payment to procure a whole new proof of stake ecosystem with incentivization to all those operators. So let's talk about, this is where the gap of existing options and what we needed to become, it becomes very clear. Custom chains, of course, are too heavy. The private networks, there are no trust minimization. Roll-ups and smart contracts, they're too rigid or too slow to customize and very limited in functionalities, right? Stablecoin payments, yeah, great for money, but as I said, like they're not really for trust governance. So Workanote Network has built the offer in the middle, right? So it's a lot of overwhelming information, but now if we zoom out across all other off-chain computes, because we want to make sure we don't rebuild something which is already there, right? Or can be reused, right? And you're all familiar with all these different kind of off-chain computes, Chainlink, MPCs, which stands for multi-party computation, TE is trusted execution environments, and there are also some automation tools like Gelato or whatsoever. You see all of them here. Some of them offer very good privacy, but lack governance. Some of them offer auditability, but no staking or penalty model. Some of them offers are very developer-focused, right? But they have a fixed governance, or they are not really enterprise-ready. So there are lots of risk for any enterprises who would like to jump into a solution that is just being developed. There is no mission-critical solution running on those, and there is no huge amount in stake that if anything goes wrong. So what Workanote Network really needs to do is basically combine the logic level governance and the economic enforcement and multi-party fairness. I will get into that. So this is basically makes it even clearer, right? We can see that on every trust critical dimension, Workanote Network leads. There is no other solution here that delivers like multiple important aspects in one package. And what's most important is not really a compromise between different features, but is actually a flexibility and trust. Now let's compare Workanote Network with existing traditional enterprise infrastructure. Basically, your SaaS or software as a service platform, ERPs, Salesforce, SAPs, or cloud systems. These systems, they offer very good uptime. Of course, it's guaranteed 99.999%, but they can't guarantee correctness or fairness or auditability before or at the moment of execution. You only know it when it goes wrong. So they rely on really a post-facto audit and a manual enforcement. So if the system is down, you can later claim, good luck to get your money back. Of course you will get it, joking. Or you get some reimbursement for the future procurement. But that's not the case for the correctness. How do you prove that the correctness of the logic execution was actually true or not? How do you audit that? Do you want to hire a group of tens of employees to perform an audit on the large data set and very complex infrastructures and logic executions? So now I just want to show you all different types of the governance that we need to deal with. And these are the governance, it means who can actually be the validator of a particular logic. It could be a private setup, or it could be a geographically distributed. For example, if you have some solution which is by the government offers in Australia, they might not be feeling comfortable that the operators are not residing there. How do you hold them liable? Or there should be some restricted KYCs, right? Of course, for enterprises to feel comfortable in order for their business logic to put into the hands of others than themselves, or the centralized kind of cloud providers or software as a service providers, which they can be sued easily if anything goes wrong, now they need to rely on a decentralized network. But they can't simply do that. Just an interesting aspects of it, some of the enterprises we've worked with, they just simply could not run the validator node on our blockchain. And I was really curious. We had a discussion with them. So, our blockchain, we have multiple blockchains. One of them is a proof of authority blockchain, right? And it produces blocks in a round-robin way. So they take turn, the validators, to author a block. So what they told me, they said that their legal department, they informed them that what if a transaction from some part of the world which is under economic sanctions, which is also tied back to something which is a questionable kind of transaction, is included in the block that I just authored on the blockchain. So now you see the concerns that they have, right? So now just imagine why there is no openness about putting everything on the blockchain or a proof of stake or proof of authority. There need to be some KYC to perform for the governance. This is another example. This is basically just shows the traditional trust structure and the trustless assurance. On the left, you see the enterprises pay in fiat, right, which goes toward the infrastructure, integration, and services. Right? That's the traditional SaaS model. You trust the provider, the software works until it doesn't. On the right, the worker node networks enables trustless model, where assurance is actually programmed into the token layer. Here, the tokens, they're not really for payments. They are really used as a stake, and they would be slashed if the execution fails, and they would be rewarded if the node performs it correctly. So this is basically the full Energy WebEx stakeholders ecosystem, both from the Web 2 and the Web 3 aspect. Right? On the top, we have these enterprise clients, energy companies or the solution builders who design and implement the logic. And each client basically onboards through their own solution group, right? And these are independent instances of the logic coordination, whether it's for, let's say, sustainable aviation fuel issuance or a grid balancing. Different types of the solution groups. On the top is actually specifically has nothing from the Web3 user experience. They log in, they pay with credit cards, they define some criteria, and they spin the network. They absolutely see nothing from a Web3. The logic runs on a network of worker nodes, which are secured by the tokens and staking. And at the bottom layer, you will see that the security layer, which is our regular proof-of-stake security, is the entire chain security. And you will see the personas on the left, that these are the compute providers or token holders. They are actually connected to those personas on the top. This is very important, you know. In our use case, enterprise clients are directly connected to our token holders, or we call it compute providers. Why? Because without their existence, the security is zero of the solution. Yeah, I know there are lots of proof of stake. You stake your token to provide security for the chain, but in this case, the enterprises need to run those worker nodes on an off-chain compute. Off-chain compute, the people need to provide the stake separately from the chain security. So now that you have seen the full stakeholder ecosystem, I want to walk you through what it actually feels like to be like an enterprise solution builder or a typical business user, someone who is really not a crypto developer, but really needs a secure way to automate this business process. Let's go through this. So what we have is we have a business first, like software as a service experience, like just any other kind of software as a service model. There is no blockchain complexity or the logic creation, right? And without the need for them to touch Web3 directly. So this is what it looks like from a business analyst perspective. They just start with defining some kind of process using our low or no code environment. Of course, they can also get any details of very complex coding as well. But remember, this is not to run entire compute. This is to run the part that is really critical and should be multi-party and trustless. So the interfaces for them is very easy. And then they launch it in a governed network. Then you'll see that the nodes on the network, the compute providers, they opt in. They basically stake their tokens. And what the enterprises get at the end, they get a temporary-proof, auditable outcome, which is really protected by economic guarantees. So this is an example of how a trustless assurance looks like and is defined, right? As an example here, we have got like 16 nodes. Each of them need to stake around $110,000 and giving a total around 1.7 in total backing, right? And nearly half of it is really at risk. Why? Because the consensus requirement is like 51%. So it means 49% is really at the consensus risk. You can configure all those kind of different requirements, like the quorum, the voting rounds, the locking periods, and every single aspect of it. And these are all programmable per each use case. So these are really tied back to the real-world business use cases, that they can define it and they can be governed. They do not see any coding. That is very important. If you would like to do something similar to this, you need to actually create your own complete custom chain. So this is how it actually works. It's enforced. The assurance is enforced when those defined requirements, it actually gets published on the EnergyWebX blockchain. Then the operators will actually opt in. They stake their tokens, they perform the executions, and they submit the proofs, and they get paid. Or they get slashed based on how they perform. And the EnergyWebX blockchain is basically a fully transparent and automatic way for this to be enforced. So let's shift the perspective now. Let's make it quicker, like to the compute provider. This is someone who actually wants to earn by running the nodes or by providing the infrastructure to the network. They might be a cloud provider, or it could be a data center, or even advanced prosumer, or even it could be anyone at home without any knowledge of how to run a node. So it's very important. No technical knowledge required. That was really our expectation for token holders for running a multi-party computation. So we don't ask our token holders to speculate. We actually invite them to contribute. So they can contribute by staking tokens and running those nodes, and they can earn rewards. And now currently, like just launched a network over a year. We have 10 million tokens. It's on chain. It has been locked by the holders. Then they are part of the consensus of the worker node operations. So we have two different types of the worker nodes implementations. We have it as a desktop application or a server-based. And you see that this is really the gateway for anyone to join. There is no tech background needed. The desktop application is also available on all these platforms like Mac, Windows, and Linux, and is also downloadable in the Apple App Store. So just imagine, someone without any knowledge on the Web3, they just need to know how to download an app, how to have a wallet, and connect their wallets, and they stake the tokens, and the compute just runs on the background, and they can earn income from it. But those incomes are tied back to the actual business solution. So this is just like how we build it. So the app itself is an Electron package application, but it comes with all the necessary back-end logics and storage, and also integrates with all those system keychains for secure credentials. And it also embeds the worker node execution engine, the node execution engine environment, directly inside the app. So even though it looks like a simple desktop app, it's really a full Web3-enabled compute. So now let's look at how the trust is enforced, or not just go through a software, but also economically. Just to quickly show you what happens under the hood, this is a structure of the worker node palettes on the blockchain, that each solution group is configured by the group registrar. And then you have defining all the voting rules, rewards, and the eligible participations. And the solutions which are created by solution registrars are defining all the logics. The worker node operators on the other side, they're staking the tokens, they're subscribing to those groups, and they're running the computes, and then they are voting on the results on-chain. And based on the accuracy of the participation, they will receive rewards. All of it are enforced on-chain palettes on EnergyWebX. So this is where the Web3 gets really interesting. So you can stake your EWT, and in return, you get a liquid EWT. And this is basically our new tokenomics design that is going live this year. And we have solutions from clients who are paying in Bitcoin or USDC. So what happens, it means you stake your EWT, in return, you get liquid staking, because you already provided security on the security layer of the chain. And then your liquid EWT basically is your entry ticket into the solutions that is governed. Of course, you need to fulfill the criteria as well, right? If you stake those tokens are basically protecting the real enterprise compute jobs. And in return, you will get rewarded in different assets. So this actually means by contributing compute, you don't just earn more EWT, but you can really unlock a whole new asset like Flow, like Bitcoin, or the stable coins. And these are really paid by market demands. So I think that's it from my side. Thanks a lot, and feel free to reach out. We will be excited to collaborate. Thank you.